This is Brian Metzger. Welcome to part 2 of the first module, and let's get going on the training section. Now, we saw in the first video that the first question, out of the top 10, starting this countdown, that isotopes was the topic, and that students could not eliminate answer C from the decision. So they either selected it or they selected E, because they knew that D was correct, but they couldn't, again, eliminate C, so then they selected C and D. So we discussed that the issue is they could not look at the the atomic number as well as the weight to say, no, this is not an isotope, this is just a cation, with a plus symbol. It's missing an electron, but this is not a definition of an isotope. So we need to understand the definition of an isotope. So isotopes are the atoms of the same element, so they have the same number of protons, but they have different number of neutrons. This is the critical thing. And of course some isotopes are radioactive, but not all of them. And then you can think of this flow chart to help you. So atoms of the same element, but if they have different number of neutrons, this is not a charge issue, because neutrons have zero charge, but they do have mass. And so isotopes of the same elements have different masses, but isotopes of the same elements have the same charge. So that's the key, that if you look back at the answer, the wrong response of choice C, you see you've got a different charge, but we know that isotopes have the same charge. They just have different mass. So here's an example of carbon, 6 neutrons, 7 neutrons. The charge, again, is 0. It's the mass difference, because you add an extra neutron, you go up AMU by 1, so you go from carbon 12 to carbon 13, and that's what we just said. So there's carbon 13. And hydrogen is another example, and this is actually very common. You have hydrogen with 1 proton, 0 neutrons is basically a proton, right? So they call it protium. And then if you have 1 proton and 1 neutron, it's deuterium, sort of heavy water as they call it. And then if you have 1 proton and 2 neutrons, it's tritium. So you can look at how you would display that. There's hydrogen, with a mass of 1 and 1 proton, and then deuterium, which has 1 proton but the mass is 2, and then this is tritium, where the number of protons is 1 but the mass is 3. So that tells you that you have 2 neutrons in tritium. Okay, so that's the Z value and the mass, and you can check it out in this section to help you out. One way to help on these problems is to make a little table like described here, where you have the isotope and this is the mass number, and sulfur, so you can identify the atomic number, the number of protons. So because it is neutral, that it will have the same number of protons as electrons, so you can write the 16 and the 16. And then with neutrons, it's basically the mass, which is given here in this written, minus the number of protons. So 32 minus 16, so 16 is the number of neutrons. Now in this case, bromine 79, you do the same thing. Again, it's a neutral species, no charge, so therefore it has the same number of protons as electrons, so you can write that in, but then to know how many neutrons, you take 79 minus the number of protons, and that finds that you have 44 neutrons. So that's an isotope of bromine. Alright, so the next video will go into some other questions that look very similar to this, so we can make sure that we are very clear on the topic of isotopes. Thanks very much. Bye.